Well, that's simple. It's all in the hydrogen fuel cell. This cell converts hydrogen and oxygen that we get from electrolysis into electricity and water. It's technically called a reversible PEM fuel cell. PEM stands for proton exchange membrane. This is in the direct middle of the fuel cell. It separates the anode, as known as the hydrogen side, and the cathode, as known as the oxygen side. To break it down more, I'll start with the anode. This is where the hydrogen molecules start. A catalyst splits them into positively charged ions and electrons, otherwise known as a negatively charged hydrogen ion. The positively charged hydrogen ion travels through tiny holes in the PEM to the cathode on the other side. The holes in the PEM are just the size to let only the positive hydrogen ions through, nothing else, hence the name proton exchange membrane. So that's where the positive hydrogen ions go. I'll get to where they end up a little later. The negatively charged hydrogen ions are where we get the actual energy to run the car from. From the anode, the negatively charged hydrogen ions are conducted by metal plates in the fuel cell through a separate circuit with an electric load, such as a motor. In other words, an electric current flows from cathode to anode, which runs the motor. Now that we've covered the anode and the hydrogen molecule, it's time to move on to the cathode. At the cathode, oxygen molecules are being stored. When the positively charged hydrogen ions come from the anode, they react with the oxygen molecules, forming our second product, H2O, otherwise known as water. In conclusion, the hydrogen fuel cell takes hydrogen and oxygen molecules that they get from electrolysis and turns them into the electricity needed to run the car, and water as the only waste product. What are alternate forms of transportation besides using gas? It's a very good question. The answer is there are electric cars, which use a battery, hydrogen-powered cars, which although there aren't that many made, could be a thing in the future, and these use a hydrogen fuel cell. There is parallel hybrid cars, which use electric power and gas power, and they convert motion into energy. There is also regular hybrid cars, which can use oil or gas powered and have a battery, but they do not convert motion into energy like parallel hybrid cars do. There are examples of each of these. For example, right here is the Chevy Volt. It's an electric car. Same with the Nissan Leaf. These are both examples of electric cars that use batteries to run. This bus is an example of a parallel hybrid system. It is an example of just like our buses that we have here in Oshkosh called Go Transit. For the time they use braking, when they are not using the gas, they convert that energy into electric power to actually run the bus. They also have gas to power the car and when they run out of electric power. There's also hydrogen cars that could be made, but there's not a lot of models made today, but it could be a thing in the future. So now you know what are the alternate transportations besides using gas-powered cars. Okay, so the question is, what would be the effect of switching to a hydrogen or an electric-based transportation system? What effect would that have on our economy? Well, that is very easy to answer. There would be a drastic effect on our economy because we are extremely dependent on oil to give us jobs. Right here is the key word, dependency. We are so dependent that approximately 9.2 million people are directly or indirectly employed by the U.S. oil and natural gas industry. That's about 5.3% of our population. And if we took that away, our economy would drop beyond repair. Okay, here are some examples. In the first graph, as you can see on the first graph, there are pipelines crossing the entire country. To be specific, there's about 305,000 miles of interstate and intrastate transmission pipelines. This is one example of how much our country depends on oil, because that is how much oil is being made. On the second graph, as you can see, our oil usage isn't going to stop. Now that Obama is going to serve another 4 years, it's going to go, our production of oil is only going to rise more and more, as it did in 09, 2010, and 2011. In the third graph, you see the actual impact that it has on the jobs of our production of oil. And you can see the projections through 2030. Experts think that it's only going to rise the amount of jobs. So if we took that away and switched to a hydrogen-based economy, we would lose all those jobs. Not only that, we would also have to replace all our gas stations, all our petroleum gas stations, with hydrogen-based gas stations, and we just don't have the money to do that. So that is why we can't switch to an all hydrogen or electric-based transportation system.
Industrialized countries. American colonists used the windmills to grind wheat and corn, pump water, and cut woods. In the early 1920s, Americans used small windmills to generate electricity in the rural areas. With cut electric service in 1930s, power lines were just